diggy hole, and let's add custom ore generation to our Minecraft mod. 121 Minecraft modding course is available down below, with over 11 hours of content covering everything from the basics all the way to block entities and custom mobs. Alright, friends, back IntelliJones more, and in this tutorial we'll be adding custom ore generation to our Minecraft mod. Now, extremely important, if you have come to this tutorial without seeing the last one, you will need to watch the last one, because that is where we add the 3 classes basically absolutely needed, right? These are absolute classes that you definitely need for our world gen over here, for the origin. Otherwise you will not be able to proceed. Now, either you watch the previous tutorial, or you can also go to the description below. All of the code is always available in the GitHub repository, so you can basically check it out there as well. Now, in the first step right here, before we're going to touch any of the craziness that is world gen, specifically ore generation, we're first of all going to add 2 more blocks to our Minecraft mod over here, and that's going to be the end ore and the nether ore. Now, we're going to do this a little bit faster, so once again, all of the code will be available down below, but basically, I'm just going to copy over the things that we have. Basically, it's going to be the bismuth end ore over here and the bismuth nether ore. And like I said, we're going to do this in sort of record time. So we're just going to go through the basic steps, right? It's going to actually drop the same ways that the ore drops do with the create multiple ore drops. I think that is going to be the, good kind over here. I think that's going to be the, first of all, the end ore, and we'll also have the nether ore. As per usual, I mean, most people have probably already switched off over here or have gone like to the next step, but basically, of course, there's also timestamps in the description, so you can always jump to whatever you need for the tutorial as well. This is going to be the nether ore and the end ore. That's going to be fine. Absolutely freaking fantastic. And then when it comes to the items themselves, well, that's just a block with item, very straightforward for both the end ore as well as the nether ore. Nether ore, there we go. That's going to generate those 2. And then, of course, the translation, just so that you have this. Like I said, we're just going to get this completely out of the way. There is end ore and the nether ore. And then, of course, the textures, which will also be available to you down below. Now, why do I add them? Well, obviously, because what we're going to have is we're also going to spawn ores both in the end as well as in the nether. So, obviously, that is when we need both an end ore and a nether ore, because that is sometimes a thing that people ask, hey, how do I spawn those, those ores as well? And you will find it's actually more straightforward than you might think. And we're going to, of course, start with the configured features to give a tiny bit of a retrospect on how world generation works. There are 3 steps to it for us, right? This is going to be a simplification, but this is going to hopefully suffice on how it works. We're going to have a configured feature, which we're going to configure in just a second. These configured features tell the game, okay, how can I place something in, or rather, what is the shape? How is it going to look like what I'm going to place in the world? In our case, we're going to say this is how many ores are going to spawn in one vein. That's the whole idea. That is our configured feature. Then we're going to have a placed feature, which is going to be, hey, how is this going to be placed inside of the world, right? And when I say how, it's like how many of them are going to be in one chunk, for example, things like that. And then the biome modifier, which is the BM right here, that is going to be in what biomes will we place this place feature. That's the whole idea. That is the thing that we're going to go through. So we're going to start with a public static final, and this is going to be a resource key of type configured feature of type question mark, comma, question mark. Looks pretty crazy, but overall, really, you shouldn't be confused by this. It's just going to be a generic as they come, a configured feature. And that's going to be, first of all, the overworld underscore bismuth underscore ore underscore key. And that's going to be equal to the register key method. And we're going to pass in a name that's going to be the bismuth underscore ore. And now we're going to duplicate this 2 times. Now, very importantly, we're going to rename the first one to the nether bismuth ore key. And then also extremely important, instead of the name, we are going to rename this too. If you forget to rename the name over here or change the name in the register key method call, you're going to run into a lot of issues. So double check this, triple check this. I've seen every single permutation of error that you might imagine in this case already. So you always want to double check the spelling. Even I spell things wrong more often than you might think. You might not see it because we do have a thing that we call video editing, which sometimes that's really useful. I can tell you that. Now, in the bootstrap method, where we will register our configured feature, we first of all, for our ores, have to define a rule test. Now, this rule test works as follows. You can think of the ores as the following. We're going to define the ores in a second, and then we'll also say, okay, what can these ores replace? Meaning, obviously, when we have our overworld bismuth ore, then we have a normal bismuth ore, which is a stone-based texture, right? If we look at the textures, then we can see, obviously, the deep slate ore is embedded in deep slate, and the normal bismuth ore is embedded in stone. So obviously, it wouldn't make any sense for this particular ore to be spawning inside of deep slate. That should make a lot of sense, and you should be like, oh, okay, of course. So that is what we need to define now, and that's going to be defined with rule tests over here, and those are going to be 4 different rule tests. I'm going to write down the first one, and then I'm going to copy over the rest. Once again, all the code is available down below, and we're going to see. So this is going to be the stone replaceables equal to a new tag match test passing in a block tags dot, and this is going to be the stone ore replaceables. Idea being that the tag over here contains every single block that a stone ore, meaning this type of ore right here, can replace. This includes things like tuff and things like that, right? So obviously, it's not only stone that could be replaced, but there's other things in the ground, other blocks in the ground that could also be replaced. And for the other ones, I'm going to just copy them over. You can see we have the deep slate replaceables, which obviously, once again, has a deep slate or replaceables match over here. We then have a netherrack replaceables, which needs a block match test for netherrack because there's no like netherrack replaceable. I think there might be a netherrack replaceables as well, but in this case, netherrack is going to be fine. And then the end, or once again, a block match test over here for endstone, right? So this is going to be the blocks that can be replaced by our ores. Now, how do we define this? Super freaking simple. For the overworld ores, we need to make a list. And for the other two, so both the netherrack and the end ores, we don't need to make a list. That's going to be handled sort of in line. So we're going to make a list over here. And this is going to be of ore configuration dot target block state. Looks crazy, but we're going to be fine. This is going to be the overworld bismuth ores equal to a list dot of. And then we're going to, first of all, add a ore configuration dot target, passing in the stone replaceable. So this is going to be the targeting of, hey, this is the test that you have to test for, right? You're going to scan through the world. You're going to find, oh, I would like to place the following block there, right? The block that I want to place is modblocks dot this is the bismuth ore.get.default block state. This is the block that I want to place there. And then I'm going to say, okay, is this part of the stone replaceables? And if it, let's say we scan and it's a deep slate ore, they're going to be like, absolutely not. You're not allowed to place the bismuth ore there. However, in the second thing that is inside of the list, right, we're going to add the second thing here. But that is going to be, this is going to be deep slate replaceables here in the second line. And this is going to also be the deep slate ore, right? Here, of course, it would be able to be placed within the deep slate. Hopefully understandable, and that's just a basic list because we basically have the ore and the deep slate ore both sort of added together, and that's the idea. Now, this is the thing that we need to do beforehand, right? So this is sort of the setup, and now we can actually go on to adding the actual register call because we want to call the register method that we've defined right here, passing in, first of all, the context, then passing in the key that we want to, well, define this as. This is going to be the overworld key. Then the type of feature that we want to do. Now we want to do feature.ore, right? You can see this is going to be an ore feature. I highly recommend what you do also. You can control left click on this and you can actually see where this is used, right? Sometimes you need to go to the little settings over here and make sure that the scope is set to all places. And then you'll be able to find the ore features class. And here you have access to the most powerful tool known in Minecraft modding, which is called the Minecraft source code, of course. And this is going to be absolutely amazing because you can see there's soul sand ore. Basically, how is soul sand placed? Well, you can see it's placed with rule test 3. We can move over here. We can find this. Oh, we're block match testing for netherrack. Look at this. Exactly the same thing that we're doing as well. And this is super freaking useful. And you can also see this for the place features and see how they're placed. We're going to see this in a second. This is so useful. You don't even know. Like literally, it's so freaking useful. So then when we have to find that this is an ore feature, we then make a new ore configuration because, of course, we now know what the feature is, and this is now the configuration. Ergo, a configured feature. See where the name comes from? There it is. Passing in here the overworld bismuth ores, and then the second parameter here is going to be a size. And like I said, this is the size of the vein, right? So because we're basically defining, okay, what is going to be the size of our configured feature, or what is the shape? How is it going to look like? That's a rough idea. And what we can then do is 2 more register calls. So another register call here with the context, then passing in the nether bismuth ore key, once again, feature.ore, of course, right? Feature.ore. And this is going to have as well a new ore configuration, this time passing in the netherrack replaceables. And then we also need to pass in the block state that we want. In this case, modblocks dot, this is going to be the nether ore. Yes, the nether ore dot get dot default block state, and then the size here as well. What we can then do is actually duplicate the second one. And of course here, we need to take special care that we actually change everything we need to change. First, the key to end bismuth ore, then change the netherrack replaceables to the end replaceables, and then here, change it to the end ore as well. You can double check that you have used all of them by, well, control left clicking on the end bismuth ore key, and then it should bring you to the exact register call. The same thing with the end replaceables. It should bring you here, and then here, just check for the end ore, and then you know you're good to go. Of course, as always, you can also double check the code in the description below. And this is the mod configure features class done. We now have our 3 different configured features sort of registered. And if I were to now run data gen, it would already work and it would generate these configured features. However, of course, that is not quite everything we need because we somehow need to place them inside of the world via a placed feature. Now, before we tackle this, we need to copy over a different class. Reason for this is sadly that there are 3 extremely great methods that we could use that are going to make this just a little bit easier. They're not too crazy. It's like we could also do this all inline, but I'm just going to do this. This is going to be the mod ore placement class, also available down below. And what we're going to find is if I were to search for, so shift twice, and then we look for the ore placements, I believe is the class name. Yes, ore placements. Then what we're going to find, first of all, here are all the place features for vanilla. So once again, super freaking useful, right? So how is, let's take a look at maybe, I don't even know, iron. There you go, iron middle. How is that placed? There's a common ore placement with 10 and a height range placement over here of a triangle between -24 Y level and plus 56 Y level. That is how this is placed. Super freaking useful. You know exactly, basically, or, you know, most of you know, okay, roughly, okay, this is roughly how coal works, right? This is roughly how gold works. You have everything here. Highly recommended to take a look at this. And what you'll find here is that you have the same methods, right, that we've just added over here. The ore placement, common or rare ore placement. You have exactly those available here as well. However, if we were to look at them, they're all private for some reason. Well, I mean, for some reason, because they're only used in the ore placements method, but really, like, they should just be public and then we should be good to go. But whatever the case may be, we can just copy them over. Super simple. They're not like that hard to take a look at. And there we go. Now, for the place features, what do you think is the first thing that we'll need? Of course, we'll need resource keys. That is the first thing that we'll always need. And that's going to be not a public string, but it's going to be a public static final resource key of type a placed feature here in this case. First of all, going to be the bismuth underscore ore underscore place underscore key equal to, once again, the register key method with the name bismuth underscore ore underscore placed. I always highly recommend to add the placed over here in any of your placed features, and you always know, oh, this is a placed feature. We're going to duplicate this twice again. I'm going to call the next one here the nether bismuth ore, and then, of course, instead of the name, instead of the register key call, also calling it nether, then end underscore bismuth here, and then, of course, end underscore bismuth here too. And we have all 3 of our place features, or rather our resource keys for the place features done. Now we already have the configured features holder lookup that we need. And we're going to see why we need this in a second. But basically, we then can register, not the register key, but the register method, passing in the context again, passing in the key. So this is going to be, first of all, the bismuth ore key for the overworld ores. And now we need to somehow say, well, what is the configured feature that we want to take a look at? Well, the configured feature we want to take a look at can be done via the configured features dot get or throw, and then we can define mod configured features dot overworld bismuth ore key, and that is the whole idea. After the first closing parentheses, we then define a list of placement modifiers, and the way to do this is we're going to say mod ore placements or placement dot, and then we want to say, is this going to be a common ore placement or a rare ore placement? Now, in our case, I think that this is going to be a common placement where we simply need a count. So there's going to be, let's say, 12, and then a placement modifier. Now, this placement modifier, this usually is the height range over here. Now, the height range we can do via height range placement dot, and then we can either do a custom height provider. We're not going to do that, or we can do a triangle or a uniform. Now, in this case, I want a uniform distribution with a vertical anchor, which is going to be the following: a vertical anchor of an absolute -64 And then the second parameter of the uniform is going to be a vertical anchor, which is also going to be absolute of, let's say, 80. And then I'm going to explain what the frick all of this means. So the height range placement, like I said, we can do either a uniform or a triangle. Now the idea is as follows. When we have a uniform distribution, so this basically determines the distribution of placement of your ores in the Y level, right? The count just says this is roughly how many different veins I want to have of this particular ore, right? Defining the bismuth ore key right here in a chunk. That's roughly what this says. It's a little more complicated than this, but this is a good overview to think about. And then we're going to have a height placement because obviously we need to know, okay, at what Y level do we want to place them? Because diamonds, you know, they go down way deeper, right? Coal starts way higher up. And then also there's like coal that, you know, spawns in the mountains and things like that. So we need to somehow be able to define this. Now a uniform distribution means that between now, in this case, between Y level minus 64 and plus 80 Y level, between those two, there's going to be a uniform distribution, meaning that all of them have the same likelihood, right? So let's look at this a little bit more simplistic than it actually is, right? But just for the sake of argument, there are 144 levels, Y levels, where these could spawn, right? And there's 12 of them that could spawn. So in theory, right, what would happen is there's like a 8.3% chance per Y level that one of them spawns because there's a uniform distribution, meaning each Y level has the same likelihood. That's the idea here. Okay, we have this figured out. That is awesome. Now what we can do is we can duplicate this twice and do the same thing here for the nether ore and the end ore. And of course, always nether ore here, and then if we want to change the placement here, of course, we can change the numbers. That is always up to you. And then end here, and of course, end here. We can also change the numbers here, but we don't have to. But one thing that you probably have in mind is, okay, but what is a triangle? Aha. And now we get to the juicy things. Because in a triangle height range placement, the distribution is a triangle, meaning the lowest likelihood is at minus 64 and 80, and the highest likelihood is between the two, which would be, if I recall correctly, should be 16, right? Because that's where the triangle meets, right? If you draw a triangle, that's, you know, from minus 64, and then you draw it upwards to 80, and then you try to meet it in the middle as a triangle, so to speak, then what you're going to have is the middle is going to be the highest distribution, and as you go up and down, it's going to be lower and lower. That's the whole idea, and that is the triangle formation. And that is basically the two ways that you can do this. Now, obviously, in the height range placement over here, you could, in theory, also make a custom height provider. Now, I believe there are a couple of different ones, or a weighted list. There's a very bias towards bottom. So you can also use a couple of those and simply use those that exist here and just change it up. You can also, in theory, make your own if you wanted to. Now, that is completely beyond the scope of this video in this case. However, there's a lot of different ways that you can basically place your ores, which is really cool. And once again, also, I cannot recommend enough. We've just seen the ore placements class as well. Take a look at this. Always take a look at vanilla. It is the best resource that you have at your disposal for anything, because you already know how this is going to work, right? You already know, okay, I roughly know how dirt is going to be placed between 0 and 160. I roughly know how that works. I roughly know how gravel works, things like that. You know how these things work. That is why I'm telling you, take a look at the vanilla values and how vanilla does it, and that is always the best place for inspiration. But of course, with the place feature, we're not done quite just yet, because right now, where would we place this? In what biome is this going to be placed in? Of course, it is not placed in any biome because we still have not added the biome modifier. Now, the biome modifier is, like I have previously told you, a part of NeoForge, but you can actually also see here because the biome modifier key is actually via NeoForge. And here, of course, we also need 3 resource keys. This is going to be a thing that is simply going to happen every time. And this is going to be a resource key of a biome modifier. In this case, I'm going to call this the add_bismuth_ore, not pre, but or, equal to the register key method, add_bismuth_ore. Absolutely fantastic. And of course, duplicate this twice. And let's not forget to change the names to add nether bismuth ore. And here as well, very important that we change the name instead of the method call. And then here it's the end bismuth ore, not emd, but end. And same thing here, _end bismuth ore. And then instead of the bootstrap method, how is this going to look like? It's going to look a little bit different, but also not that bad. Context.register. We're going to then pass in the resource key again. So it's going to be the add bismuth ore. We then want to make a new biome modifier. Now there's a couple of them. We can do a biome modifier, and we can see there is an add features biome modifier. This is the one we want to take, and we can actually go into the biome modifiers class and take a look. There's the add feature. There is the remove feature. Very interesting. There is also, I believe, the add spawns. This would be for spawning spawner data, in this case an entity. And there's also a remove spawn, so we can remove this. There's carvers, so this is for, you know, like cave carvers and things like that. We can also remove them. And there's also a spawn cost. I actually don't know what that is. A stock biome modifier that adds spawn cost to a biome. I don't even know what that is. Apparently, add mob charge. Well, there you go. Apparently, there's a spawn cost. I actually have not seen the spawn setting stuff over here, so I don't quite know what that is, but fair enough. Whatever the case may be, though, the add features and the remove features is probably the two that we're going to use the most. But in this case, we're just going to use the add feature. Now, the added feature needs a couple of things. It needs a biome or biomes to spawn it in. We can actually double check this. You can see a holder set of biome. So we need biomes to spawn this in. We need a placement. So this is going to be the feature, the place feature, and then a regeneration step. First of all, we're going to do the following. In case of this, I want this to spawn in the entire world. So we're going to say biomes.getOrThrow, biome tags dot, this is going to be is_overworld because I want this to spawn in the entire overworld. Then we're going to have a holder set direct of a placed features dot getOrThrow. Remember, the placed features here is the context lookup of placed features. And this is going to be mod placed features dot bismuth or placed key, exactly. And then this is going to be for the underground ores as a generation step. And that's it. This is now all we need in this case. Now we're going to duplicate this once again 2 more times. And from the top to the bottom, this is going to be, first of all, the Nether bismuth ore, where we're going to spawn this inside of is_nether. And of course, we're going to spawn, very importantly, the Nether placed key right here. So that's going to be fine. And then lastly, we have the end one. That's going to be the end ore, not the entity. That would be ridiculous. This is the add end bismuth ore is_end. And we're going to place the end bismuth ore. Very importantly, we're using a tag right here. If you do not want a tag, but you want it to specify 1 or more different biomes, what you'll use is, instead of biomes.getOrThrow, I'm going to say holder set.direct biomes.getOrThrow. Let's say, for example, biome.plains. And then we can add more. We can keep it at 1, right? You can see you could keep it at 1 in this case, or we can add more. Just call the biomes.getOrThrow again. And then we have, for example, the savanna or something. So that would work as well. I'm going to just keep this here as an example, right? So this is going to be the example for individual biomes here, let's say. Something like that, right? You don't have to have this, but, you know, just in case, if you say, hey, I actually only want my bismuth ore to spawn, in certain biomes, then you can totally do that. That is absolutely possible. And that is the way to do it. Now, with this done, we've stepped through quite a few things, hopefully understandably, and hopefully you now understand each one of these different things. What do they do? How do they connect with each other? And how all of this fits together. And now that we have this, we can now go to our data gen over here and run this. Of course, once again, this is all, well, the prerequisite was all the world gen setup, because that is done in here. So if we were to, let's see, check it out, you can see that the bootstrap methods here are of course called in the mod data pack provider. Very important that we have this. And if we weren't, well, then it wouldn't work. That's why I, in the very beginning of the tutorial, told you to basically go back and watch this. And we'd see 17 JSON files written. Now, a couple of those are also from the loot and the state providers here for the new blocks, but we can actually see in data tutorial mode world gen, we have now 2 things, or a couple of things actually, configured features as well as place features. And what we're going to find is, let's say the bismuth ore, we can see this is an ore feature. And we want to place bismuth ore with, and we can replace that with ore replaceables, as you can see. Awesome. It's going to be 9 of them. And then when we have this configured feature, where do we want to place this, or how do we want to place this? We want to place this via a trapezoid height range between -64 and +80. And this is going to have a trapezoid or a triangle distribution with 12 of them basically spawning. And then lastly, here in tutorial mode's NeoForge biomodifiers, we're going to add this, right? It's going to be adding a feature. The feature we're going to add is the bismuth ore placed via the step underground ores, and we're going to place them in every overworld biome. That is what we have. And with this done, we can jump into the game and see if it works. Now for this, we're going to make a new world in this case, and if you do make a new world, what might happen, now in this case it's not going to happen, but you might get an error or a warning, hey, we have different data pack stuff. This might also happen if you join this world or rejoin this world, so just keep that in mind. But of course, it's not always going to be the thing, so we're going to actually add ourselves a night vision over here, infinite amplifier, and we don't want to show the, oh, we actually do want to show them. No, hide particles. Well, there you go. So that's going to be a true. There we go. And then what we can do is just go down and we can see. We can't find our ore. What do we have? Bismuth. Oh, there it is. Look at that. We got some bismuth ore. And of course, if we were to go down a little bit further, we might even be lucky. And there we freaking have it. We got some bismuth ore right here as well. And you can see right here, it seems to spawn a little bit more. This is -4. So this is obviously a little bit higher. Now, it should, in theory, if I recall correctly, around 16 like height level, it should be about the most. But obviously, in terms of the distribution, it's always going to be, you know, I mean, it's random, right? You know, just because we have a distribution, it's still going to be random, but there we freaking go. And now we find ourselves in the Nether, and this is going to be quite interesting indeed, because this sometimes is going to take a little while longer to actually find the freaking ores over here. So, oh, well, spoke too soon. There it is. There is the bismuth netherrack ore. Absolutely freaking fantastic. That also spawns. That is, you know, basically making sure that the sanity works, and then jumping into the end. I mean, look at this. We can immediately freaking see that there's stuff right here. And of course, that should spawn basically an entire end island, including also all of the other islands, by the way. But we can see, there we go. Look at this. That's going to be pretty nice. Luckily, in the end, it's really simple to find your ores if they spawn or not. But yeah, there you go. That is custom ore generation added to Minecraft. Absolutely freaking fantastic, man. As per usual, all of the code is available down below, but that's going to be it for this tutorial right here. Next time in this video, we'll make a custom tree. Hope to see you there. So, yeah.